This is section 2.1, Inequalities. First, we're going to go through and look through some vocab real quick. An inequality is just a statement that two quantities might not be equal. Now, again, we've got four different choices over here. We've got less than or equal to, greater than or equal to. One thing you want to pay attention to, you're always going to read these equations or these signs from left to right. So as you're going from left to right, this is less than. So that's the easiest way to remember it. We will talk about, the alligator eating the bigger number and things like that. But in terms of when you say it, we want to work on saying it correctly. The next vocab word that we're going to look at is open interval. That's a set of numbers between two values where the endpoints are not included. To notate an open interval, we're going to use parentheses. And then a closed interval means the endpoints are solutions. That's where we'll use brackets. And then that means that 2, for the example over here, 2 and 5 would also be included in our correct answer. All right, so down here in this little table, we're going to sort of talk about what the notation looks like and then how we graph it. I'm just going to put A here and B here. Rather than marking every single graph, just kind of say that A is the one on the left, B is the one on the right. This first one says that X is trapped between A and B. Now, because I have parentheses, I know that I'm going to just put a less than sign. We always want our less than signs to go from left to right, especially when we have these compound notations. If it's just one or the other, that's okay, but for the most part, we want to go left to right. Then this tells us it's open circle, and then shade in between. The next one, because it's bracket, that means less than or equal to, and that's going to tell me a closed circle. Okay, the rest of these are just kind of combinations. Again, the setup's going to be really similar. Over here, this first one's a bracket, so that's a less than or equal to. Then I have a parenthesis, so that's less than. So again, make it match up, closed circle, open circle, shade in between. So obviously you can see all these different combinations. We have lots of combinations that are possible. So let's go ahead and fill these in, these next two. All right, the next things. Now you see this infinity symbol. Infinity always has a parenthesis because it's impossible to include infinity as an endpoint. This one tells us we're going to go from A to infinity. Now, I don't like this notation. Oh, sorry, that should be an infinity. I don't like this notation here just because it doesn't really make sense. But what you can think of is if you kind of write it out this way and then just sort of ignore the infinity stuff, you're like, oh, this means that A is less than X, which really means that X is greater than A. So that's a good way to kind of remember it. Now, you do want to shade all the way through, and then please go ahead and shade the arrowhead. That shows us that it keeps going on forever. Same thing here, greater than or equal to, so that's going to be a closed circle, shade, and then finish up the line. Okay, down here, again, we're going to go from negative infinity to X. Don't love the negative infinity part, so I'm going to get rid of that. And then the part I do see is X is less than B. Now, eventually, you're not going to have to keep writing it as the compound. You're just going to know that, like, hey, from negative infinity to B, that means I'm looking for all the numbers that are less than B. And here's our closed circle. And then shade that. All right, the last one is negative infinity to positive infinity. We can't write an inequality. That's basically just all real numbers. So we're going to shade the entire number line. You're going to end up answering in all sorts of different formats as we keep going through. Okay, down at the bottom of the page, we talk about how we're going to solve inequalities. This is really similar to what we've been doing before in terms of opposite operations. The only thing is right here. Okay, when you multiply or divide by a negative, you must switch the inequality. Now, that's only when you're multiplying or dividing by a negative. If there just happens to be a negative in the problem, then that's different. So we'll kind of look through some examples as we go through. Okay, here's our first example, trying to solve for X. So opposite operations, subtract 4. And then I'm going to divide by negative 3. Now, if you sort of say this out loud to yourself, you just heard me say divide by negative 3, that means I need to flip the sign. So now, instead of a less than, it becomes a greater than. So my answer is X is greater than negative 7/3. Now, I do want to practice writing it in interval notation also. So x is greater than negative 7/3 means I'm going to start at negative 7/3 and I'm going to go on forever to infinity. In terms of graphing it, I'm going to put a 0 here about in the middle. Negative 7/3 is actually negative 2 1/3. So I'm going to go just a little bit past negative 2. So negative 1, negative 2. Open circle, and then we're going to shade the numbers that are bigger than negative 7/3, and so that's going to go to the right. All right, in terms of this one, now we've got variables and expressions. We got stuff on both sides. I'm going to subtract 2x over here, and then I'm going to add 3 to the other side. Now you'll notice there were some positives, there were some negatives, but so far I have not yet multiplied or divided by a negative. And divide by 2 still have not multiplied or divided by a negative, so we get to just keep it how it is. Final answer is x is less than or equal to 4. So that means as interval, I'm going to go from negative infinity and then stop at 4. 4 does need to be included. So again, let's go 1, 2, 3, 4. It is or equal to, so that's a closed circle. I'm looking for numbers that are less than 4, so I'm going to shade that way. So again, we need to get good at solving and answering in all sorts of these different methods. Okay, next you'll see the compound inequalities. This means the variable is trapped between two inequalities. You may split the inequalities, or you may solve them as one big inequality. I actually prefer that method. If we can keep them together, I think that you're going to be better off. Normal inequality rules still apply. Multiply or divide by negative, you've got to flip it. And then the big thing, the signs always must be facing the same direction at the end. And let's try to get in the habit of going from least to greatest. Okay, so that means your signs should look like this: less than or equal to, or just less than, whatever. Okay, so here we go. I'm focusing on this x. I got to get the x by itself. So first I'm going to add 4 to both sides. So this gives me negative 2. And then this gives me 6. Next, I'm going to divide everything by 2. Negative 1, x, and 3. I've not multiplied or divided at all by negative, so no flipping of signs is necessary. And I'm done. So in terms of interval notation, let's see, this is an or equal to, so that's going to be a bracket. That's just less than, so that's going to be a parenthesis. Again, double check to make sure our signs are going from left to right. Here's my 0, closed circle at 1, negative 1, open circle at 3, shade in between. So we're going to trap our x values between 2 points. All right, next one. I'm going to multiply both sides by 2. Now, on the left side, I did take negative 5 times 2, but because I was really multiplying by 2, I was taking something times positive 2, I don't need to switch the signs. Subtract 4, so now I'll get negative 14 is less than negative 3x is less than or equal to, let's see, negative 3. Oh, sorry, I forgot to multiply this by 2. So that should be a 2 there. So then when I subtract, I'm getting negative 2. There we go. Now I'm going to divide by negative 3. Now when we divide by negative 3, we need to flip the signs. And now again, I think it's going to be better than if we just go ahead and flip our inequality. So basically everything's just going to be a gigantic mirror image. Now the alligator, again, I know it's kind of a silly notation or silly way to think of it, but it works. Okay, right here the alligator was eating the 14/3. Over here the alligator's eating the 14/3 also. In terms of interval notation, it's going to look like this. Sorry again about the fractions. Let's see, 2/3, I'm going to have a closed circle right there. 14/3 is just shy of 5, so 1, 2, 3, 4, 5, open circle, and shade in between. Okay, so there's compound inequalities. The last thing we're going to talk about are called absolute value inequalities, and those come from, you're going to see the way we solve them is really similar to what we just did. Now, right here, this thing, Gorland, you'll hear me say this all the time in terms of when you look at an absolute value inequality, I'll say, hey, Gorland, and then, you know, this is kind of a reminder that we want to split it up, and this is how we solve absolute value inequalities. Now, one thing I do want you to make a note of, over here, if we ever say that the absolute value of A is less than, let's say, a negative number, okay, this one's going to be no solution, right? Because if you take the absolute value, there's no way to make it less than 10. This guy, this is going to be all reals. Sorry about that. This is going to be all reals because anytime you take the absolute value, you're going to get a positive number. If it's greater than a negative, every single positive is greater than that negative. So that's going to be all reals. So those are two kind of little examples you just need to be aware of. Now, if it's comparing the absolute value to just a positive number, that's when we talk about this imaginary place called Goreland. So we're going to read our absolute value from left to right. I read this guy and I see it's a less than sign. Less than is right here for land. The L stands for less than. So this is a less than problem. And then it says and. So that means the variable is trapped between the negative value and the positive value. So I'm going to rewrite it without the absolute value. I'm going to trap it between the 0.5 and the negative 0.5. Okay, once we get here, it's just a compound inequality like we just solved. We're going to add 3 to both sides and get 2.5 is less than x, which is less than 3.5. Interval notation should look like this. And then when we go to graph it, let's see, 1, 2.5, open circle, 3.5, right there. Okay. Last one, read the inequality from left to right. We see our inequality sign that is a greater than, so that's an or. So what that tells us, if we look back at the top, we're going to write two inequalities. So the first one is easy. You're just going to ignore the absolute value. You're just going to solve like normal. The other inequality, we're going to flip and we're going to flip. So flip the inequality sign and flip the sign of the number. So here's our two equations. So 2x plus 3 is greater than or equal to 9. That's just normal. 2x plus 3, that part stays the same, but I'm going to flip and I'm going to flip. So flip the inequality sign and then flip the sign of the, it should be sign of a number from a positive to a negative. Again, if it were a negative, then this one would be either all reals or no solution depending on what we had. So again, just watch out for those negatives, please, guys. Let's subtract 3 and then divide. So I get one answer is x is greater than or equal to 3. Subtract 3, divide, no changing of the signs during the problem. All right, so now I have two different things. Now in terms of interval notation, this one says 3 to infinity. This one says negative infinity to negative 6. Oops, sorry, that's a bracket. Now, we're going to put these together. Most of the time, I'm going to try to actually flip the order. I'm going to say negative infinity to negative 6, right? Because that's going from smaller to biggest. And then I'm going to put this u. Now, it actually stands for union. It's the union. That's just a different way to join intervals in set notation. It's basically just the math word for and. So this tells us that x can fall either between from negative infinity to negative 6, or it can go from 3 to infinity. So I'm going to have to count by 2s just because this one is a little small. And then let's see, I've got a closed circle at 3 going to the right, getting greater thans, and I've got a closed circle at negative 6 going to the left, getting less thans. Now, I'd set it up in the notes and the typing, but I didn't actually say it. You should have two separate inequalities because you have two ors. So again, we talked about Goreland, so that's an or inequality. And then if you look at our picture, it looks like oars from a boat. So pretend like you're in the middle, you're just kind of standing out here. Your goal is to have an oar on either side of the boat. If you have two oars on one side, obviously you're just going to go in a circle. So that's another way that I kind of remember that with gore, I should have two inequalities. When I shade, I should have two inequalities going opposite directions. And that's the end of section 2.6, some intro to inequalities.